Hello, this is Professor Talat Ahmad, Professor of Geology at the University of Delhi and Vice Chancellor Jamia Millia Islamia, New Delhi. Today we are going to discuss about the classification of igneous rocks. As you know that the igneous rocks are those rocks which are formed by melting of either the crust or the mantle or a combination of these two. So, on the surface of the earth and beneath, there are lots of rocks that come out and get exposed on the surface of the earth. There are different ways of classifying the igneous rocks. The most common being the classification based on the mineralogy, the minerals that is present in the rock, which we can see through naked eye or through lens or through microscope, and that is called mineralogical classification. We can also classify the rocks using its texture, whether it is coarse grained or fine grained or medium grained, and whether the rock contains same size minerals or different size of minerals. If they are different with ground mass which is very fine and coarse grained crystals, then it is called porphyritic texture. If it is all uniform grained, coarse grained, it is called phanetic rocks, as well as phaneric rocks. And when it is very, very fine grained to almost glassy, then it is called aphanitic rocks. So, we will be looking at different types of classification being used. The rocks that are very fine grained to almost glassy, it is not possible to identify the minerals. So, classifying these rocks based on minerals is difficult. So, we use chemical classification, which will be done by analyzing the rock for different elements and then make a chemical classification which proxies the minerals that are present in the rock types. So, in general, the igneous rocks will have composition which will be either mafic rocks, which is magnesium and iron rich rock, or felsic rocks, which is mostly aluminum and silicon rock. And then there will be a mixing of these two, and also some rocks which are called as ultramafic rocks. In general, the composition of the igneous rocks contain silica from about 45% to 70%. So, it goes from ultramafic range to mafic range and then to felsic range. So, we will see this in the classifications being shown to you now. Okay, so as we discussed that the rocks, igneous rocks, they could be either coarse grained or fine grained. The coarse grained rocks will have bigger crystals, easy to identify, but the fine grained rocks, they have to be analyzed for their chemistry, or under the thin section with the microscope, we can identify few of the minerals. So, what we are seeing here in general, that the rock minerals that are present in the rocks, you can see here the major minerals which are present. This is potash feldspar or orthoclase, quartz, Then sodium and calcium feldspar, that is plagioclase, and minor muscovite mica, some biotite mica, amphibole, pyroxene, and olivine. So, what you see is that, say, approximately this side of the diagram, we have more mafic minerals, magnesium and iron rich, and here you have more calcium rich feldspar. When you come to this side of the diagram, what you see is that you have quartz, which is silica, as I told you, that it will be more rich in the different rock types. If they are formed from in the crust, they will have more of quartz and orthoclase feldspars, and to some extent mica. So, amphibole can be present from more felsic rocks to more mafic rocks. So, what we can show you here is that, say, these are rocks which are plutonic rocks. Plutonic rocks mean the rock which has formed at some depth. So, if they form at some depth, they will have bigger crystals. You can identify the crystals, but these are the rocks which are extrusive rocks, which are lava flow. It comes on the surface of the earth and they crystallize very quickly, they cool down very quickly. So, the plutonic rocks, or the rocks which are shown here as intrusive rocks, they are also called as plutonic rocks. So, they go from more felsic means silica and alumina rich, to intermediate rocks between felsic and mafic and ultramafic. So, ultramafic rocks will be those rocks which will be basically having only olivine and pyroxene. Mafic rocks will have pyroxene, plagioclase, and to some extent olivine and amphibole. Intermediate rocks will have some feldspars, potash feldspars or the orthoclase, quartz, and more sodic plagioclase, or you can say albite end, and then we have the biotite and amphibole. And when it comes to the felsic rocks, these are mostly silica rich rocks, so it will have more of orthoclase, more of quartz, some sodic plagioclase, that is albite, some muscovite. So, what we see here is that from felsic end to the ultramafic end, the mineralogy changes. You do not see quartz present in ultramafic rocks because they cannot exist together. Similarly, you cannot see olivine or pyroxene in granite or rhyolite because it is not possible, because they do not have magnesium and iron. So, now you can see here is that the intrusive rocks are listed here and its equivalent. Say if it freezes or crystallizes at some depth, okay, there will be these plutonic rocks. These are those rocks which are same composition but extrusive. It comes on the surface as lava flow. So, when we have granite at the depth, we will have rhyolite on the surface as lava flow, and the composition will be orthoclase, quartz, albite or sodic plagioclase, and muscovite, and to some extent biotite, and to some extent also amphibole. So, this is the more silica rich rock. Now, this is intermediate, which is granodiorite as the plutonic rock, its equivalent dacite as the surface or the exclusive rock. So, this will have, as you can see, the amount of orthoclase will be lesser, and then you see andesite, the amount becomes even lesser for this, and also the amount of quartz will be lesser compared to granite in the granodiorite and dacite, or diorite and andesite. So this becomes intermediate rocks. So it will have all the minerals, but the proportion of these minerals present in granodiorite and diorite will be less of orthoclase, less of quartz, more of sodic to calcic plagioclase, and more of biotite and more of amphibole. When it comes to mafic rocks, it is at the depth it is called gabbro. At the when it becomes more mafic, it becomes peridotite. Mafic means more olivine rich and pyroxene rich, and then when it is mostly olivine rich, it is called as dunite. So its equivalent when it comes to the surface, because they are very fine grained, so they are all together collectively called as basalt. So basalt encompasses big range from gabbro to peridotite to dunite, but now dunite and to some extent peridotite are also classified as komatiite and verlite, that I will be showing you in the classification. So this is the general classification based on mineralogy, how the mineralogy changes and the rock type changes. So what we see is from left to right, we go from more felsic to intermediate to basic to ultra basic, or more mafic rocks on the right and ultramafic rocks on the right, and more felsic rocks on the left. So the mineralogy also goes from more K-feldspar, orthoclase, when it is more acidic rocks, more granitic rocks, and when it comes to ultramafic rocks, it is olivine and pyroxene. So when it is more of pyroxene and plagioclase together, they form gabbroic rocks or the mafic rocks or the basic rocks. So this diagram is mostly based on the minerals present. So it has to be for a plutonic rock which crystallizes at some depth and gives rise to these different minerals. So now this is another classification which is classification recommended for by the IUGS, International Union for Geological Sciences, recommended for the phaneritic rocks, the rocks which are full of crystals. So when it is quartz rich, so quartz, alkali feldspar, potash, and these are the plagioclase, and then these are the feldspathoid. So what we see is the more common minerals, and now you can see here that one side is quartz, another is feldspathoid. So if you have a rock like granite, it will not have any mineral of feldspathoid group in this. So this is the division. So above this are more saturated rocks, and these are called as undersaturated rocks. So as you can see that if it is more than 90% quartz, Q is quartz, so then it is called as quartzolite. When it is 90% to 60% quartz and less than 10% or more than 10% to 30% of alkali feldspar and plagioclase, it is called quartz-rich granitoid. And then when they have between 60 and 20% of quartz, okay, it will be, and the presence of more alkali feldspar, it is called alkali feldspar granite. This portion, the rocks which will fall here will be called as granite. When the granite has more plagioclase, okay, it is called granodiorite, and when it has more plagioclase and quartz and very little alkali feldspar, it is called as proctolite. Now, when the quartz is less than 20% and it is more rich in alkali feldspar and plagioclase, it is called as alkali quartz cyanite, then quartz cyanite, quartz bonzonite, quartz bonzodiorite, and quartz diorite. So, like that you can see that the presence of quartz is present here. So, they are called, so you go from very rich rocks in quartz to less quartz and more of alkali feldspar and plagioclase. So, like this the classification goes, and these are all plutonic rocks. Plutonic rocks means those rocks which will crystallize at some depth and will have enough time to form bigger crystals which you can see through naked eye. Similarly, when you come to the other side where the silica is less, very little silica, no free quartz, then you will have foids and then bonzocyanites, foid cyanite. So, these are other group of rocks which will not have any free silica, no quartz will be present, but it will have feldspathoid, alkali feldspar and plagioclase. So, these are two ends. So, the rocks can be divided into quartz rich or also known as the silica saturated rock. These are the undersaturated or silica undersaturated rocks. Now, as I told you that if you go from more felsic rocks, which is quartz bearing, these are more mafic rocks. So, in mafic rocks, what we are showing here is plagioclase, pyroxene and olivine. So, rocks which is more than 90% of plagioclase, it is called as anorthosite. Rocks which has a combination of plagioclase as well as pyroxene, it is called as gabbro. When it is combination of olivine and plagioclase, it is called troctolite, but the most common is the olivine gabbro, where you will have composition which will bear both olivine, plagioclase and pyroxene. It is known as olivine gabbro. And the ones which has very little plagioclase, it is more of pyroxene and olivine, it is called plagioclase bearing ultramafic rocks. So, now we have more felsic, more mafic, and these are the alkaline rocks or undersaturated rocks. So, these are the classifications based on mineralogy, and in which you have more than 10% quartz, feldspar and feldspathoid present, and then these ones are the more mafic rocks. Now, if you see, we have rocks which are more of olivine, orthopyroxene, clinopyroxene. In the last mafic rocks, we had plagioclase. Now, what we have is, it is all mafic minerals. This is olivine, orthopyroxene and clinopyroxene. The rocks which has more than 90% of olivine is known as dunite. If it has more than 90% of orthopyroxene, it is called orthopyroxenite. If it is more than 90% of pyroxene or clinopyroxene, it is called clinopyroxenite. And then now you can see here that there is a divide of 40% of olivine. Here it will be less than 40% of olivine, and rocks which are having more than 40% olivine, say for example this side, orthopyroxene and olivine together will form Harzbergite. Similarly, olivine and clinopyroxene will form Verlite, but for both these rocks, the olivine has to be more than 40%. Now, less than 40%, what we have here is olivine websterite. So, websterite is orthoparoxene and clinoparoxene rich, where you have less than 10% of olivine. So, it is called websterite. When it is more than 10% of olivine present, this is called as olivine websterite. And on this end, if you have less olivine and more of orthoparoxene, it is called olivine orthoparoxenite, or you can say olivine bearing orthoparoxenite. Similarly, on this end, it will be olivine clinoparoxene paroxenite. So, this is clinoparoxene, this is olivine. So, it is called paroxenite. The rocks which are in general term you will say is this is known as pyroxenite. The whole rock series is called as peridotite. So, peridotite can be pyroxenite, it can be also more closer to laharzolite or dunite. So, this is the general term for ultramafic rocks, which will have silica SiO2 less than 45%. When it comes to ultramafic rocks, and if it is a plutonic rock, then what we see is that it will have more of olivine, orthoparoxene and clinoparoxene. So, different combinations are there in terms of the minerals. In this, if you will see that there is no mention of plagioclase. So, this is more apt for ultramafic rocks, because ultramafic rocks will not have plagioclases. So, minerals are present will allow you to classify the rocks into dunite or orthoparoxenite or clinoparoxenite. Collectively, they can be known as more of ultramafic rocks, giving different names. Let us see, this is another diagram which is equivalent to what we have seen for the coarse grained rock. Now, this is for very, very fine grained rocks. So, fine grained rocks, what we see is when it is granite, in the other case here it is rhyolite, okay. Where it is granodiorite, these are dacite, and then similarly we have trachyte, latite, andesite, basalt. So, these are all volcanic rocks which are equivalent to the granite and gabbro series, where you have silica present. This side is again undersaturated rocks, which is again more of a volcanic rock, where you have very, very fine grained rocks. So, what we get here is phonolite, tephrite, void bearing andesite, void bearing latite and void bearing trachyte. So, this is the IUGS, or International Geological International Union for Geological Science. This is the classification given based on the mineralogy. Now, you see here this is another classification which is for rocks which are volcanic rocks. It is extrusive rocks, it comes on the surface, but it also brings lots of breccia, lots of agglomerates, okay, like blocks and bombs. You will have lots of rock crystals in this. So, these are also known as agglomerates or pyroclastic breccia. Okay. Many times the lava flow that comes and flows on the surface, but it also goes out in the air. It can go up to 300 kilometers in the air and then settle down in the form of tuff. So, if you have say lapilli is again very, very fine grain glassy material. This is ash. So, you will have blocks or bombs, ash and lapilli. So, you can have agglomerates, tufischous braccia, lapilli, tuff is the material which goes in the air and then comes and settles down. So if it is only ash, it is called tuff. It has ash and some other minerals or rock grains. It is called as tufischous tuff braccia. And if it has more of lapilli, it is called as lapilli stone. Okay, now let us see for those rocks which are very, very fine grained. As I said that in these rocks you cannot see the minerals present. So these rocks are crushed and analyzed for their major elements. Okay, so what we see here is that it is called as TAS diagram, total alkali. So this is Na2O plus K2O is called alkali, total alkali, and this is silica. So this is very famous diagram known as alkali silica diagram or TAS diagram. This is given by Lee-Matter. So what we see here, like earlier classification based on mineral present is ultra basic, basic, intermediate and acidic. Now we don't say ultramafic, because ultramafic we say when the minerals are identified and they are here it is more acidic and basic. So acidic is rocks which are more silica rich. Ultra basics are those rocks which are very, very poor in silica. So the silica percentage here is less than 45%. So these are, if minerals are present and if it is plutonic, it will be known as ultramafic. These will be known as basic and mafic, where you have silica between 45 and 52%, it is called basic rocks, or when you have mineralogy available, it is called mafic rocks. These are intermediate rocks where you have silica, SiO2, from 52 to 63%. So this is called intermediate rocks, like what we have seen in the case of mineralogy, it was diorite and granodiorite. And then we have acidic rocks which is 63% onwards. More than 63% is called acidic rocks, okay, which is also called as granitic rocks when the minerals are present. So now you can see here that these are rocks which are known as picrobasalt, which is because of the very, very low percentage of silica and also very, very low sodium and potassium together is here, less than 3%. So if it is less than 3% of Na2O plus K2O and silica and SiO2 from 41 to 45, it is called picrobasalt. If it is same level of Na2O plus K2O, but it has more SiO2 from 45 to 52, it is called as basalt. And then as you can see that when you go up towards more silica, you also see that the amount of sodium and potassium also increases. So when it increases, it is known as basaltic andesite. When it has silica percentage from 52 to 57%, it is called as andesite. When it is 57% silica, between 57 and 63, and it has much higher, up to 5-6% of Na2O plus K2O. And then dacite, you can see that it goes from 63% and up to 73 or 75%, so it is called as dacite. And when you come here, rhyolite is very, very high silica rock, very, very high silica, and it has very high Na2O plus K2O. So now you can see again that if you see this line, above this line we have rocks which are known as alkaline rocks, or also alkaline rocks means which has more alkali, and it is also called as silica under saturated rocks, as we have seen in earlier classification. So, when we have more Na2O plus K2O more than 5% and same composition as basalt in terms of silica, it is called as trachybasalt. Okay, when it has more sodium potassium, it is called as tephrite or basanite. When we have 5% onwards of Na2O and K2O, and the silica level also goes from 53 to 57 and goes less, it becomes trachyandesite, basaltic trachyandesite, and trachydesite. So, desite, trachydesite. Similarly, andesite, trachyandesite. Basaltic andesite, basaltic trachyandesite. So, with the increase in the amount of Na2O and K2O, the rock name changes. And then when it has very high Na2O and K2O and it has void minerals, okay, these are called as phonotephrite, tephrite phonolite. So, like that, this is again a classification for rocks which are very fine grained. So, if we cannot see the mineralogy based on the based on the mineral chemistry, we can classify them as you have seen. Now, another important thing that we can see here is that we have here some of the rocks which are very strange names: Hawite, meteorite, bembrorite. So, these are rocks which has very high, or they have when it is more sodium than potassium, it is called Hawite, and then when it is almost Na2O is about 2% and K2O less than 2%, it is called as potassic trachyllite and then shoshonite. So, these are different ways in which a rock is classified into saturated and undersaturated rock. This is applicable for rocks which are very fine grained extrusive rocks. These extrusive rocks are those rocks which comes to the surface of the earth and explodes, and then they spread over as lava flows. And because they come to the surface, they freeze very quickly, so they don't get much time to have bigger crystals. So, they will be either glassy or very fine grained, very fine grained rocks. These rocks are better classified based on the chemistry of the rocks rather than mineralogy of the rocks. So, they are called as chemical classification of the rocks, and then they can be basic, they can be intermediate, they can be ultra basic, and as opposed to the mineralogy, when we say basic, it is equivalent to mafic. When it is ultra basic, it is equivalent to ultramafic, and when it is felsic, it is more of a granitic rocks. So, these are some of the very fine grained rocks. Rhyolites, for example, is the extrusive equivalent of granite, and granite we can easily classify based on the minerals present, but rhyolite we cannot, because we cannot see any mineral, we can see only glass and very fine grained minerals. So, these are different advantages and disadvantages of the rock classification based on mineralogy and rock classification based on the chemistry. Okay, so we can summarize the talk that I gave earlier, that the igneous rocks, since there are lots of variation in the type of igneous rocks, they have been classified based on presence of the minerals, and where you cannot identify the minerals because they are very, very fine grained, we use the chemical classification to classify the rocks.